Hi, this is the certification video for the Lulzbot Taz 5 3D printer at the Arapahoe Libraries Castlewood branch. Before we proceed, let me explain what it means to become certified on this machine. You will be allowed to reserve this printer online and operate it on your own without direct staff involvement. You can reserve the 3D printer for up to 30 hours per month. This is total 3D printer reservation time, so if you are certified on our other 3D printer, those hours can be split between the two machines. And we are offering this service for free. To clarify, this is a new process, so there may be changes as we figure things out. We will do our best to communicate any changes, but please email us if you have any questions. Our email address is techspecialists@arapahoelibraries.org. Okay, you're still watching, so I'm guessing that all sounds good to you. A few more logistics. You need to have a library card with us, Arapahoe Libraries. If you don't have one yet, no worries. If you're a Colorado resident, we should be able to get you signed up, no problem. We also have a liability waiver you'll need to sign. So if you're under 18, please make sure to have a parent or guardian available to sign yours. Alrighty, moving on. Certification is a 3-step process. Watching this video is step 1. Step 2 is completing a short quiz about the content covered here. And step 3 is a practical assessment. You'll need to schedule an appointment with one of our technology specialists for a time when you can come into the library and do some 3D printing to show us what you've learned. If all goes well, then you'll be certified and can reserve the printer to use it solo. But if you feel you aren't ready after that, we're happy to continue helping you learn until you feel comfortable operating the machine on your own. Okay, let's get started. This printer is the Lulzbot Taz 5. It can print with different kinds of materials, but for now, certification only covers printing with ABS plastic. We are investigating the possibility of creating an add-on certification video for people interested in printing with different materials. But for now, it's just ABS plastic. The build volume of this printer is approximately 11 inches by 11 inches by 10 inches. You could look up the exact dimensions online. And it prints from an SD card. When you are preparing the 3D printer, you need to look at both the filament and the plate. The filament should be loaded into the extruder and appear untangled. The plate should be flat, secured at all 4 corners, and have blue painter's tape over the glass. When printing with ABS plastic, we found that a surface of blue painter's tape plus a thin layer of Elmer's glue stick gives us the most reliable print surface. The prints adhere well to the plate, but are not too difficult to remove when complete. The plate should also not have any debris from the previous print. Let's take a minute here to look at the LCD interface for this printer. There is a small silver button that you spin and press to navigate the different menus. When you come in for your practical assessment, feel free to explore the menus here. On the main screen, you'll see the set temperature for our extruder and the heated bed, and the measured temperature of each one. When the printer is running, you'll see the file name of the item being printed, in addition to the elapsed time for the print. One important thing to keep in mind, if you spin the silver button while on the main screen, you actually are adjusting the filament feed rate, as indicated by this FR value. Changing the feed rate here is not a good idea, and if you are having inexplicable print problems, it's worth double checking that this FR number is at the correct 100% value. If you accidentally change it, just change it back to 100% and everything will probably be fine. Although we are not allowing different materials at this time, only ABS plastic, you are welcome to change the filament color. If you decide you want to change the filament color, first, you'll need to heat up the extruder. You press the silver button and scroll to the temperature menu. You should see the option for ABS. Select ABS to begin heating. Our extruder will be set to 240 degrees Celsius and our heated bed will be set to 110 Celsius. Although we only need to heat the extruder at this point to change the filament, we are heating the bed here as well because it's a slower process and you'll need it heated when you want to start your print. While the extruder is heating up, We'll want to raise it a bit above the plate so we have room to extrude some filament. Using the silver button, navigate to Movement, Move Axes, 1 millimeter, and Move Z. Once you are here, you can spin the button clockwise to raise the extruder up. Keep in mind, each click of the button will move the extruder 1 millimeter on the Z axis. It's probably a good idea to move it up at least 50 millimeters, but there's no need to be precise here. Alright, by now our extruder has heated up and we are ready to change the filament. Double check that our extruder temperature is at 240 degrees Celsius. We don't want to try to remove filament unless it has been correctly heated. Take a look at our extruder. The filament is held in place by a few different pieces here. First, we have our extruder motor that grips the filament and pushes it down into the nozzle. There's a piece on the left that holds the filament tightly against the extruder motor and a third piece on top that clips this entire mechanism together. You are going to unclip the extruder mechanism by lifting up on the top piece. It's held in place by 2 screws. The tension of these screws is very important. Most of the time, you will be able to lift this piece without having to loosen the screws. If you can, that's probably the easiest way to do it. However, if this piece is clipped in too tightly, loosen the screws a little bit, but do not remove them. And, this is very important, remember how much you loosened them by. You will need to return them back to their original tension in a minute. So, unclip the top clip, and the left piece will fall open, exposing the extruder motor. At this point, you can just pull the filament out of the extruder. Next, you'll want to remove the filament from the filament guide tube, secure the end by holding it, and remove the old spool. Wind up any loose filament and secure the end of the spool. If you don't do this, the spool can and probably will tangle, which will cause a lot of problems for the next person using that color. Now, get the filament out that you want to use. Make sure that it's ABS plastic and 2.85 millimeters diameter. Please do not bring your own filament. We appreciate that you may want to contribute, but filament variations can really gunk up extruders, so we are happy to provide the filament for these prints. If you notice we are running low, let us know and we'll order more. Loosen the end of the new spool and hold it in your hand. Load the spool into the spool holder and thread the filament through the guide tube. Cut a fresh end on the end of the filament. Load the filament by basically doing the opposite of what you just did to remove it. Press the filament end into the extruder. You'll feel it sink into the nozzle and you won't be able to push it any further. Then, lift up on the left side piece. It will press the filament against the extruder motor. Now, slide the clip in place to hold it all together. If you loosened the screws before, now is when you retighten them. The screw tension is important because if the screws are too tight, it will pinch the filament too hard and nothing will extrude. If the screws are too loose, it won't hold the filament tightly enough and nothing will be extruded. It's a delicate balance, so please take care to return the extruder mechanism to its original state whenever you are changing filament. Now our filament is loaded in the extruder and everything is reassembled, so it's time to extrude and see if plastic comes out. Using the silver button, navigate to Movement, Move Axes, 1 millimeter, Extruder. Turn the silver button clockwise to tell the extruder motor to extrude filament. Each click is 1 millimeter of filament extruded. You'll want to turn it very slowly at first, otherwise the firmware has a tendency to crash. You should see some filament start to come out the tip of the nozzle. It will probably be the old color at first, but then switch to your new color. If it's not extruding, press down on the filament where it enters the extruder. That should get it going. Go ahead and extrude about 100 millimeters of filament just to ensure that everything is working correctly. Once you have the filament taken care of, it's time to check the plate. First, make sure the plate appears flat, secured at all four corners, and has blue painter's tape over the glass, specifically on the area of the plate you will be printing on. The tape does not have to be perfect. It can have some bumps or imperfections and will still work fine. If you have to put new tape on the plate, you'll want to press it down hard to help it adhere really well to the glass. It's not absolutely necessary, but we recommend checking the Z home position before each print. This printer allows you to manually set the distance between the extruder and the plate. When I say Z home position, I mean the spot on the vertical axis that the printer sees as 0. When you are checking the Z home position, you'll want the distance between the extruder and the plate to be about the same as the thickness of a piece of paper. Why is this important? If the extruder is too close to the plate, it will dig into the tape, and extrusion might stop if the plastic has no room to go anywhere. Even if it keeps extruding, your print quality will suffer. If your extruder is too far from the plate, your print's first layer will not stick to the plate properly, and your print will be unsuccessful. So how do we determine the Z home position? First, we tell the printer to travel to its home position. Use the silver button to navigate to Movement, Auto Home. Once the extruder reaches home, use a piece of paper to feel between the extruder nozzle and the plate. Please keep in mind that the extruder may be very hot, so please take care not to burn yourself. Also, if the extruder is hot, a small amount of filament may have extruded and get in the way of your paper. Try to use the piece of paper or another tool like a screwdriver to brush away the filament so you have a clear space between the nozzle and the plate. Please do not use your hand to remove a small piece of filament from a hot extruder. Sliding the paper back and forth in the area between the extruder and the plate, you should be able to move it, but still feel a little friction. This is something you'll get better at the more you do it. Luckily, this printer is pretty tolerant of a relatively wide range of distances between the plate and the nozzle. If the distance feels good, you can slide the paper and you still feel some friction, then you are good to move on to printing your file. But what about if you need to adjust the Z home position? There is a small black screw on the left side of the printer near the extruder's home position. As the extruder travels downwards to the plate, this screw presses into a switch called the end stop switch. When that switch is pressed, the printer knows it has reached the bottom of its Z-axis and stops moving. So basically, when that switch is pressed, the printer is at Z equals 0. We can loosen or tighten that screw to tell the printer to stop at a higher or lower position. If our nozzle is too close to the plate, so we can't slide the paper between the nozzle and the plate, then we need to loosen the black screw by turning it counterclockwise. That will tell the printer it should stop at a higher position on the Z-axis. Once you adjust the screw, you have to use the silver button to re-home the axes. That will reposition the extruder at its new 0 point, and you can measure the new distance with a piece of paper. If the nozzle is too far away from the plate, so if we can't feel any friction on the paper when we are sliding it, then we need to tighten the black screw by turning it clockwise. That will tell the printer it should stop at a lower position on the Z-axis. Again, once you adjust the screw, re-home the axes and test the distance again. If you aren't sure which way to turn the screw, try it one way. If the situation doesn't get better, then try it the other way. Once your Z-home position is correct, you are probably good to start your print. However, you do have the option to check the Z-home position at other spots on the plate. If your print is limited to the center area of the plate, you may want to check the Z-home position at the plate center. Use the silver button to navigate to Movement, Auto Home. Then move the X and Y positions so the extruder is near the center of the plate. Using the silver button, navigate to Movement, Move Axes, 10 millimeters, X-axis. Turn the silver button to tell the extruder to move along the X-axis. Each click is 10 millimeters of travel. Do the same for the y-axis to position the extruder in the center of the plate. At this point, use the piece of paper to feel the distance between the nozzle and the plate. Remember, both the extruder and the plate may be hot, so please take care not to burn yourself. You should be able to move the paper and feel some friction from the nozzle. If you need to adjust the Z home position, adjust the screw and then auto home. The reason we say this part isn't necessary for every print is that it's really easy to get caught up in making the distance between the plate and the nozzle perfect, when in reality, this printer will probably work fine. You can just start your print, and if the first few layers print successfully, then you're good to go. If they don't, then you can come back and troubleshoot the Z home position until you get it correctly distanced from the plate. If you think the plate is significantly not level, you also have the option of adjusting the tension of one or more of the plate corners. Adjusting that tension will affect the overall level of the plate. Adjusting the corners is something that is not usually necessary, and we don't generally recommend changing the tension of these screws. However, if you are printing something that takes up the entire plate area, you may want to check the Z home position at the four corners. You can test the distance with the piece of paper, and rather than making adjustments to the extruder home position with the Z home screw, you can use the corner screws to change the plate position. Each corner is held together with 3 screws. The one on top holds the glass plate in place. You don't want to tighten this one. It will have no effect on the plate level, and if it gets too tight, it will crack the plate. So please leave the top screw alone. Looking at the 2 bottom screws, one of them has a spring. The screw with the spring is the one you would adjust if you determined you needed to change the height of that corner. Again, this is not recommended between each print. Generally, you can adjust the Z home position to the correct spot and that's enough. But if you are having trouble printing and you think it might be related to plate leveling, we want to make sure you understand it's possible to adjust individual corners. Lastly, apply a thin layer of Elmer's glue stick to the area of the plate where your print will be located. This helps the plastic adhere to the platform and will greatly increase your chances of a successful print. So, to sum up the process of preparing the 3D printer, you need to look at number 1, the filament, and number 2, the plate. The filament should be loaded into the extruder and appear untangled. You have the option to change to a different filament color, but please be sure to secure the loose ends on the spool to prevent tangling. You'll want to confirm that the plate appears to be flat, and blue painter's tape covers the plate surface. Also, that there is a thin layer of Elmer's glue stick in the area where you'll be printing. You'll probably want to check the Z home position and make sure the distance between the nozzle and the plate is about the thickness of a piece of paper. You can also check the Z home position in the middle of the plate, but that isn't generally necessary. Now you know how to prepare the printer, let's talk about how to prepare your file. First, you'll need an STL file. This video doesn't cover how to do 3D design, but there are lots of tools out there that you can use. Things like Tinkercad, Onshape, Fusion 360, SolidWorks, Printcraft, seriously, the list goes on and on. You can also come to the library and talk to a tech specialist, and we can help get you started with your design. You can go to places like Thingiverse.com and see designs that other people have created and shared. But at this point, let's assume you have an STL file that you want to print. Preparing it for 3D printing is a process called slicing, because you take your file and convert it into a collection of horizontal layers, aka slices, that when you put together, create your 3D shape. Luckily, we don't have to do this by hand. For this print, we use a software called Cura Lulzbot Edition. You can download it for free from the Lulzbot website, and it's pretty easy to find with a Google search. The software interface might look a little different from what I'm showing you here, depending on your operating system and software version, but the essentials are the same. The first time you open this software, it will give you a few options to click through. Our printer is a standard Taz 5, and we are printing with a 0.5 millimeter nozzle. Once past those initial screens, you'll see a visual representation of the 3D printer's build plate. Next, you'll need to enable some more functionality by going to the Expert menu and selecting Switch to Full Settings. Now you can open your STL file in the Cura software. You should see your design displayed on a representation of the 3D printer plate. At this point, you'll need to load one of our pre-made configuration files. We have 2 provided for you. Please use these as they contain specific settings to our machine and will ensure the best printing experience. If you want to change some of the settings, that's okay, but please use one of our configuration files as a starting point. In order to choose which configuration file you need, you should decide if you want to print your item with supports or without them. Support material is a scaffolding-like structure that the printer uses to hold up overhanging pieces of your design. Generally, if your design has horizontal overhangs, more horizontal than 45 degrees, then you'll want to select supports. They are designed to break away from your print, leaving your original design intact. Keep in mind that supports can add significant print time to your project. My STL file here does not have any horizontal overhangs, so I don't need supports. I will load the configuration file for no supports by going into the File menu. We do recommend printing with our default parameters here: a layer height of 0.2 millimeters, infill of 20%, infill being the amount of the interior of the print that is solid, and a 1 millimeter shell thickness. The shell is the solid layers on the outside of the print. However, you are welcome to change these settings. Keep in mind that printing with smaller layers or higher infill will significantly increase your print time. People often think that to make a 3D print stronger, it needs to be solid, aka 100% infill. But generally that is counterproductive. When you print a solid object, the plastic doesn't have time to adequately cool, leading to warping and a weaker overall print. If you would like advice on your print settings, we are happy to help. Just send an email with your question to techspecialists@arapahoelibraries.org. For this printer, we recommend a brim for every print. It tells the machine to extrude a few extra outlines on that first layer, which helps your print adhere to the plate. After the print is complete, the brim just peels away, leaving your original design. If you want to get more in-depth with this software, the custom print settings allow a lot more control over your print parameters. This video isn't going to cover those, but feel free to explore those settings and ask us if you have any questions. There are also buttons on the bottom of the workspace here that let you move your printer around on the plate, rotate it, and scale it. Feel free to explore using those tools. This video really isn't about troubleshooting the software, so if you are having trouble preparing your design, please let us know. We can help you. But once your file is ready and you have the settings you want, use the Save G-code button to create the .gcode file that the 3D printer can read. Cura will give you an estimate of how long your print will take. However, and this is very important, this estimate can be very, very wrong. Because of inaccuracies with some of the hard-coded acceleration values in Cura, the software underestimates the print time for the Taz 5 printer. Sometimes it is a significant underestimation. When you are determining how long your reservation needs to be, I recommend doubling the time given by Cura, and then potentially adding 10 to 20% to that value. This is especially true for longer prints. Please feel free to ask us by emailing techspecialists@arapahoelibraries.org if you'd like some advice on how long your reservation should be. We are working on figuring out a more accurate way to estimate these print times, but for now, we just want to buffer in plenty of extra time so you can be sure to finish your print during your reservation. Okay, to summarize preparing your file. You use the Cura Lulzbot Edition software to create a sliced file, which has a .gcode extension. Be sure to use one of our configuration files when preparing your print. The default parameters are recommended, 0.2 millimeter layer height, 20% infill, 1 millimeter shell thickness. A brim is recommended for all prints. Supports are recommended for prints with horizontal overhangs. You'll want to double the Cura estimate, especially for longer prints, to get an idea of how long your reservation needs to be. Feel free to ask a tech for help in determining your print time. Okay, so now you know how to prepare the printer and how to prepare your file. Operating the printer is the easy part. You load your G-code file onto the SD card. Feel free to delete files from this card if you need to make space. With that in mind, don't use the SD card as the only place to keep your print file. Once your file is loaded to the card, put it back into the printer. Please note, it goes in backwards. Use the silver button to navigate to Print from SD and scroll to your file. Press the button to start your print. The printer may need to heat up, so give it a couple minutes and your print should start. You definitely want to stick around and watch at least the first few layers of your print. If the first few layers print successfully, then chances are the rest of your print will continue with no problem. If your first few layers do not print successfully, then it's time for some troubleshooting. If plastic is extruding but not sticking to the plate, you'll want to stop the print using the silver button and the LCD screen and double check your plate preparation. Remember, the Z home distance should be about the thickness of a piece of paper, and there should be blue tape and glue stick on the printer platform. If your print isn't sticking to the plate, chances are the nozzle is a little too far away from the plate. Move it closer using the Z home screw and try your print again. If you have this error, please remember to note it on the clipboard. However, the most common and most frustrating error is when the printer just doesn't extrude plastic. It will keep moving and thinking that it's printing, but nothing is coming out. The more you 3D print, the better you will get with troubleshooting, but we've provided a little flow chart that might help you when trying to figure out why the printer is not extruding. First, you'll want to check if the filament is tangled. Visually inspect the spool and see if you can pull on the filament where it feeds into the extruder. If it's tangled, unload it, untangle it, reload it, and start your print. If that wasn't the problem, check the Z home position. Is it the correct distance from the plate? It's possible that if it's too close, the plate may be physically obstructing the plastic from coming out of the nozzle. Adjust the Z home screw to position the extruder a little farther from the plate and restart your print. If you think the Z home position is correct, go ahead and raise the extruder a few inches above the plate and extrude some filament. Does the filament extrude normally? If so, go ahead and restart your print. If not, press down on the filament while it's trying to extrude. Does any filament extrude now? If so, the extruder screw tension may be wrong. This is important. Whenever you are adjusting the screw tension, remember by how much you are changing it. If it turns out this doesn't fix it and it wasn't the problem, you'll need to adjust the screws back to the way they were. So with that in mind, adjust the screw tension and try to extrude more filament. If you're having no luck, try adjusting the screw tension the other way and seeing if that works. If you are still getting no or only partial extrusion, you may have a partially clogged extruder. We ask that you please don't take apart the extruder. There are some things you can do to try and unclog the extruder without disassembling it. First, physically push down on the filament and try to force it through the nozzle. You can also use a small pin or wire to poke up into the nozzle hole. If you want, you can try holding up a small cap full of acetone to the hot nozzle and try to dissolve the clog that way. Please be careful here, it is really hot. If you try these things and the extrusion looks better, go ahead and restart your print. If you are still having poor or no extrusion, email us at techspecialists@arapahoelibraries.org to reschedule your reservation. Again, please make a note on the clipboard if you have to do any troubleshooting. Even if you are able to resolve the problem on your own, we want to know that there was a problem. There are a few other permutations and possibilities covered in our troubleshooting chart, but we talked about the most common situations. Again, communication is key here, so please let us know by writing on the clipboard or emailing us if you are having to troubleshoot the printer. We can't fix it if we don't know it's broken. Keep in mind that you might not even need to troubleshoot at all. We just want you to feel equipped to deal with some of the more common errors that can happen when using this 3D printer. Remember, operating this printer is essentially just loading your files onto the SD card and pressing the silver button. And that's the end of the video. Thanks for watching. If you feel ready, go ahead and follow the link posted here to take a short quiz about the information we covered. At the end of the quiz, there will be additional instructions on how to schedule your practical assessment appointment. Hopefully we'll see you at the Castlewood Library soon. Bye!